Okay, we'll do that. And then we'll share the screen. It's the same screen. Okay, we're trying to record this as well. We'll see.
Are you sharing desktops? Have you switched screens to the update?
Yeah, I only have one screen. Yeah, that should be okay.
Because then if you open the Grasshopper thing, it won't appear. I mean the Rhino thing.
No, I said share screen, not like share window. I think it should be okay.
Okay.
This. I don't know what the point of using. Okay, I guess if we're fine, I'll find that and give it to them. Just hang tight, don't worry. I'm gonna give it to you. All right, so for that reduced mesh, which I don't know why it's like this, but I'm just going to drop some GHA files into here, which of course is going to. No, okay. Okay, so those two. This is just for that reduced mesh. Those two GHA files, you can literally drag and drop into your Grasshopper canvas. Then we might need to restart it again, but you probably need to restart it again. But that should solve that problem. Okay. I haven't changed anything.
We uploaded 2 new files to the OneDrive.
Yeah, there's 2 new files in the OneDrive that you can drag and drop into your canvas to install this one component reduce mesh.
So one is called Center for Civilization.gha and the other one Center for Civilization Graphs.gha.
Yeah. They were there and they were. That's what?
Remember, guys, this is a collective OneDrive. So any of you delete anything, it deletes it for everybody. So let's be careful not to delete anything. Yeah, it's next to delete, which is a stupid design feature. So you'll have to.
I think I'll find them again. Okay, so Center for Civilization GHAs. Please don't delete them. Okay. We cool? People okay? If people aren't okay, some of you guys are, right? Some of you guys are okay.
Raise your hand if you're Wordanis.
Raise your hand if you're okay.
I'm okay.
So if you're not okay and you're near someone who is okay, yeah.
Parisia?
You drag and drop them into the canvas. Did you download them? Okay, hey guys, sorry. Hang for a second. So if you download them, right, they're 2 GHA files. Yeah. Literally drag and drop into the canvas. They're not going to open. Nothing's going to happen. It's just going to actually copy their contents into your Grasshopper library folder. And then you shut it all down and you restart. Okay. That's fine. That's fine.
Yes. The question is, does Monolith work on Mac?
Probably not. I don't know.
Probably not.
I'm gonna guess probably not.
So if you have a Mac, you have to use Bootcamp.
Okay, so are we okay to start with something? Because so far at this pace, we're gonna be here till tomorrow.
Hopefully not.
All right, so what I want to do is like, so assuming you get your stuff working, okay, the definition I've given you is ready-made by a colleague of Alberto's. What's Aziz? What's his name?
Aziz.
Aziz. We'll just call him Aziz. It works very well. It's quite robust. He's added some different fail safes into there. We're not going to worry about it. It works just fine. All I want to do is give you a basic understanding of how it's working so that, I don't know, if something doesn't work fine for some reason, you have some clue as to how to fix the problem. Okay. So that said, I'm not sure, like part of me thinks it makes sense to show like a really basic version of this definition and then leave you to the more complex thing. So we can walk you through basically making a really basic version. It's not going to work for, probably half of the applications you might want to use it for, but at least you understand the logic of what's happening. And then we go into the actual thing and we basically just learn which buttons to push and which sliders to grab. Does that make enough sense as a proposition for how to learn this? So this is going to be a little bit funny, but it's going to be useful insofar as the version of Ladybug that the Aziz's definition is using is like out of date. So we don't need to replace it, but it makes sense for us to just like do some basic stuff so that you can understand how to use Ladybug, which might be useful to you. So I'm just going to go to the Ladybug tab here. Okay. You should have a Ladybug tab now if you've installed your stuff properly. And let's see, we're going to start by importing a location. Okay. So if you drop in this import location, so this is, just try to follow along with me for now. And if there's major issues, go ahead and ask a question. But if you're just getting confused over stuff that someone next to you could help with, try to solve it that way. Okay. I'm just going to follow the logic of Ladybug. This plugin has changed a lot over the years, but basically we want to get Medicine Hat as a location to work with, and you can see importing a location requires an EPW file. Okay, so I've dropped that in. I'm going to, let's see, I think I want I'm going to guess LBE. Nope, that's not right. So there's another thing in here that should open like an EPW map. Okay, this is what we want. So this one, LB, which is for Ladybug, EPW map. Okay, and if I drop a Boolean toggle into here, I can plug it into this. And now if I change it to true, I believe this thing is going to pop open an EPW map in my browser, which is sweet. Okay, this is weather data for all over the world, right? So we can search Medicine Hat. Medicine Hat. Okay, we see there are those dots there. Are one, should tell me something about it when I hover over it. Okay, if I click on it, I got 1, 2, and 3 different EPW files I could choose from for this. I'm going to choose the one from the airport because I trust airports. What do you think? I trust airports.
Yeah, I think airports.
So what we want to do is just say download from DOE, and it's going to give us a zip. Okay. And okay, there it is. So if we extract that, what we should find is we have a couple different files here. And one of them is the EPW file. Okay, so all we're doing here is we're just getting a hookup, right? We're getting a connection to a file that has basic, location data in it that we can use to make calculations or extract, location specific data about Medicine Hat. So save this somewhere where you can find it. Okay, go ahead and move that to a folder where you can get at it. So what I'm going to do once I've done that is drop in a file path component, which is just called a file path. All right, and now this is going to get plugged into the EPW file here, and we're going to right click on the path, file path, right? Say select one existing file, and now we can nav wherever you save this thing to. I think I'm not sure where I saved it to. Is it here? Medicine Hat, there it is. Can it be Medicine Hat, blah, blah, blah. EPW is the one I want. Okay, 3 different files. I want the .epw. Open. Now, if I plug a panel into this thing, I can see that it's working. It's giving me some basic data about Medicine Hat. Okay, this is Medicine Hat. I have its latitude, I have its longitude, I have its time zone, and its elevation. This is really all we need to generate solar vectors. Okay. And I believe, I'm not sure about this, we can go there if there are people that want to start tapping into other types of like data, like wind or precipitation or whatever. I'm pretty sure you can just use this as a setup for that stuff as well. Okay, so if we were, again, kind of writing this definition from scratch, which you don't have to do, but I'm doing this so that you understand the logic of the definition, right? What we would do now is we want to generate a sun path. Okay, I want to visualize data, Ladybug sun path. Okay, now this is key. The location goes to the location, and that is like honestly the most important thing to get right here. And so now if I'm going to just make it so you can see my Rhino window here as well. Okay, and maybe I'm going to hide some of this stuff not needed right now. All right, so something I'm going to suggest doing here is let's go ahead and drop a curve. I'm going to use this for my example, this outline that I've drawn, okay, a curve component into here, so that I can call this curve into Grasshopper, right click, right, set one. And if we calculate if we use an area, right, we can calculate its centroid, which gives me an easy way to plug a center point into the sun path. And I'm suggesting you do this because by default, the sun path is going to be a 0, 0, 0. But if you're working on the model from Center for Civilization, like Medicine Hat is nowhere near 0, 0, 0. So this just gives you a way to understand, like a diagram, so you can understand what's going on, right? So you can see this is a diagram of sun paths in Medicine Hat. Okay, it's based on this location. It's based on its latitude and these other factors. We could, I believe there's a way to, let's see if we can do this quick. I believe there's a way to construct a location. So yeah, we can say Ladybug construct location, which would allow us to manually set this data. And some of you guys might choose to actually do this. I think this is what I did in the other file that uses an older version of Ladybug. But the only thing I want you to understand here is like, you can see how, I don't know, what degrees make sense here? Like 0 to 360? Probably not 0, but if I plugged in degrees of latitude here, okay, you can see how the sun path changes, right, based on these values, right? If you wanted to do this, okay, right? So that's all that thing is doing, right? It's generating a solar arcs based on location on Earth, simple geometry, okay? So this is what we're using. We don't need to do this. Okay, so what else do we need to do? So again, this version of the Ladybug is a bit different. It's got this, we're going to use this input called HOIS, hours of the year or something. What do you think? Hoi, I don't know. We go with hours of the year. If I can search here, I can say LB calculate Hoi. I mean, there should be. Yeah, I think that's probably the right thing to use. I don't know where it lives. Is there? I can't. Sorry, what?
Those two bottom, the curve in the area that you have kind of.
You need to input a curve into this.
Sorry.
You need to input. I've input a curve.
Yeah, could you go back to that and stuff? 'Cause I'm lying on the-
You just take any old curve gets input into a curve component, right? Okay, let's calculate. Let's do Ladybug calculate Hoi. All right, so that's going to give me a way to plug into Hoi, right? And then I've got month, day, hour, minute inputs here, right? Now, and this is interesting. You're gonna start to see, this is where this diagram is helpful, right? It's starting to show us points on the sun path, okay? So the points on the sun path are going to be based on what, times of the year we ask it to analyze or to generate a vector for us. So typically for solar analysis, right? You guys should know this. Who can tell me what are the months that we care about? It's March. March is 3, right? So the equinoxes, this is interesting. We were talking about this the other day and I was like, yeah, the equinoxes, they should be exactly the same, you would think. Interestingly enough, they're a little bit different. So I was thinking about that when I was looking, they're like just a bit different. So I actually think it is worth it to include them here. So I've just input these values, right? If you hover over this thing, it's going to tell you this takes values from 1 to 12. I don't think I need this. I don't need this 0. So let's get rid of that. So values from 1 to 12 that represent the month that we're going to look at. Okay, so, and then I've changed the panel from its default here. It's by default not set to be multi-line data enabled. So I'm just setting it to multi-line data. So this is like a spreadsheet, okay? And boom, we're going to throw that into month. And so you should see, once you've done that, that a number of new points appear on your sun diagram, right? Your sun path diagram. All right, so the other thing would be to choose some different hours. I mean, we probably should give it a day and minute input. If we hover over this thing, we say, okay, what are the days? Integer for days 1 to 31. So let's go ahead and use what, like the 21st, typically solstice or equinox, right? So it's going to throw that into a panel, throw that into the day, okay? We're not going to, I don't think it makes sense to get into data as small as minutes. So I'm just going to throw 0 into here, which really just means it's going to use like the first minute of whatever hour. That's all that really means, okay? And then for hours, we're going to do something similar to this multi-line thing. We want to look at a number of different hours. And so what do you guys think? What makes sense? If you hover over hour, you should see it's going to go from 0 to 23, which is kind of funny. This is 24 hours in a day. Lists and grasshoppers start counting at 0. So 0 to 23. I don't know if that's going to screw up the correlation to like the way we normally think about it. It might. But let's go for like 8 in the morning, noon, 4 o'clock, 19 o'clock. What else? I can actually look, if I look in this other one, I think I did this here. 8, 10, 12, 14, and 16, copied from Aziz's thing. I don't know. I think something like that makes sense. So let's just add 10 in for another data point. And then we've got, that's what he had here, right?
He's good 14.
14? 14 and 6.
Well,
Oh,
that's 2 and 4 p.m. So Maybe it does make
Yeah.
sense to have 16 and 20, like 8 p.m.
16 and 20? Okay, so spread it out a bit more. Okay. So, okay, now I'm gonna plug this into hours. So, all right, something funny is going on here. And those of you that are good at Grasshopper should be able to tell me what it is. What's going on? Why don't we see a bunch of points all along that solar path? Anyone good at Grasshopper? in here? No, so, okay, look, I've got two lists here. All right. And right now, this component is being like, all right, so month 3 gets hour 8. Month 6 gets hour 10, right? Month 9 gets, right? And then it just wraps around. So what we want to happen is each one of these months and this date wants to get all of those hours. So what do I need to do? Yeah, that's it. We're just going to graph that. I'm going to graph that input, and then we should see. Okay, so I think this is the logic of Aziz's thing. You can see there's a gap here. If we change that back to what he was using, I believe he had 14
And 16.
and 16. So you have that's better. You get a pretty, I'd say, a nice even distribution, right, across the solar arc. Sweet. So that's the setup to basically get us a list of vectors on the other end of this thing. Okay. And so there's a total of 19 vectors, one vector for each of those data points that represents like the angle of the sun relative to this site at that moment in time. Now you could do more. I wouldn't recommend doing more. This is already a lot. What you're going to find is, you know, as you guys should know or have some sense with Grasshopper definitions, the more stuff like that you have, the longer it takes to calculate, right?
I think I'm question that might clear some things up a lot more. So this, like the sun paths, like block you put in there is essentially a bunch of stuff that we talking about design put into like,
That's correct.
right? Like it is on its own a bunch of this going on, but they just simplified it into something.
Yeah, no, the reason we're using Ladybug is because it's like a super simple tool.
But it's like simplified.
They designed this sun path thing for us to use in this way. That's
Like you could do this without the sun path, but it would look like a crazy spread.
right. You could do it with geometry. It would be much more complicated.
That's what I'm getting at. It's like this is simplifying it for us.
That's right. And while we're at it, I should mention, so we are going to want to use this thing as a diagram to help us track what we're doing. Another useful input here is the scale. So you're going to find sometimes you want to be able to change that, right? So if you just throw like a numbers slider into here, by default, it's set to 1, but this will give me the ability, it's just a diagram. So this isn't changing the vectors that it's going to use in the calculation. It's just visualization stuff, right? And I should also say by default, north is positive y, which is assuming you haven't done any crazy stuff to the file medicine hat is good. That's what we want. It is possible to rotate north here with like a number slider that, you know, goes again, like between what, negative 360, 1, 2, 3 dots, 60, right? We could spin this sucker around and that is going to change. That's going to change your vectors. You can see them changing on my panel on the right-hand side, right? So probably don't want to do that, but there might be some circumstance where, I don't know, if your file's really flipped around or whatever. I wouldn't recommend doing that. But okay, so these are the vectors we're going to use. You could use these vectors to do solar enveloping with literally any number of methods. It's actually quite simple. It relies on having something like some kind of context, or it's not necessarily context, but like an adjacent condition that you're like, I need this to be sunny. This makes like 0 sense if you don't have something that you're like, I want the sun to hit that, right? So there's a way you could do this with just like, you know, like you have a block that's your site, we extrude it, we have buildings around it that we don't want to cast sun on. We could like use curves and then extrude those curves along these vectors, slice up that block, and oh, boom, you've got like a carved solar envelope, right? Now, that's super labor intensive. The thing that I'm going to show you is the setup for what Aziz has figured out, which is like, it blew my mind. It's very, very clever. This guy is good. Aziz is good to figure this out. So basically what he's proposing is we're going to use the voxels to figure this out. Okay, and that's why we have monolith. So if I go to monolith, what we're going to want to do, and again, you're not going to have to use this definition. You're going to use the one that's already made, but I'm just hoping this is useful to you in terms of like not just being given a thing and having no understanding of what it's doing, right? So if I construct voxels, now this is this is a super weird looking plugin, I have to say. Everything about it is interesting looking. Fortunately, okay, so in this thing is going to be sitting at 0, 0, 0, but all a voxel is it's like a pixel, like in a rasterized image, right? Like in Photoshop or whatever, but it's 3D and it can have multiple channels, kind of the same way like a pixel can have multiple channels, like RGB or whatever. I don't even know if that makes sense. Probably just color and alpha is what a pixel can take. This thing can take multiple channels. You can kind of customize it, but so just to give you a sense of what's going on here, I'm going to throw this box in here, and then what am I going to do? I'm going to get the voxel points so we can have like a screen rendering of what it looks like. You can see the resolution by default is super high, so set to like 48. Maybe I'm going to throw a slider in that goes from 0 up to 96, let's say. Throw that into resolution. If I start to slide this out, okay, so each one of those points represents the centroid of a voxel, right? We could do this without monolith, but the reason we're using monolith is because we actually want the voxel, because it allows us to generate meshes that we can use, right? So the resolution of voxels you're using is like key. This is the difference between like crashing your computer. It's going to chug for like 2 hours trying to calculate your solar envelope versus having something that works like in a reasonable way. Okay, so let's see if I can remember. Now I think I need to, all right, so this is a little bit weird, but basically what we're going to do is for this example, I'm just going to do this right here. So I'm going to throw in something like a plane, okay? And I want this plane to be, in my theory here, this plane wants to be sunny. I want the sun to hit that plane. All right, that box, which is just a default box, you're not going to do it this way. You're going to use your model with curve inputs or poly surface inputs or whatever, right? But so the idea is like, okay, if I want that thing to be sunny, what can I put as like mass into that block, right? That's the question. So what we're going to do is a complicated type of intersection. I believe it's mathematical. What is this? Is it physical? Blanking on the name of this. I'll figure it out though. Don't worry. Maybe I'm going to go cheat and look in this other file. This one. Okay. Where are you? So this thing, what is this? It's a mesh ray. Okay. Intersection, it was mathematical mesh ray. Okay. This is important. This is where, there it is. Okay. The reason we're using this is because we want to intersect a mesh with a semi-infinite ray, right? Sun's rays they're rays, they're parallel, they're not converging at a point, right? All right, so I'm going to bring this surface in, this one that I made here. One. I will quickly convert it to a mesh because my intersect component takes mesh, not brep. Okay, that's the mesh. All right. Ray start point. So I'm going to use these voxel points as my ray start point. Okay, and then my direction for the ray direction is going to be these solar vectors. Okay, Now, if I look at what this thing did, first intersection, let's turn this stuff off. Okay, hasn't done anything yet. I believe it's just giving us Booleans. So Booleans are just true or false, right? It's like there's 9, so this doesn't look right. We're going to need to graft the points because we want to test all of our solar vectors at each voxel, right? So I'm going to graft those, boom, 0 through 19, false, 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 right? Yeah. Yeah, totally. Grafting is like one of these things that's like, I always find it hard to explain. But basically, when, like, literally what it does, okay, is it's the difference between having like a flat list, which is like something like this, okay, one, whatever, I think I have an extra. So let's say I have 1, 2, 3, 4. There's no hierarchy to it. There are no tree branches. It's just everything in one branch. So like maybe an easier way to show is like if I just generate a series of numbers. Okay. So series of numbers, default, right? They have a path here, 0, 0. So it's technically one data branch, but everything's just in one branch, right? It's flat. So that's like my solar vectors right now. They're just all, these are all the solar vectors I care about, right? If I graph this thing, I right click and say graph, it puts each one of those numbers into its own tree branch. Now, what's significant about this for what we're doing, or for Grasshopper anyways, is you do this when you want to run like an operation many times on a data set. It's like if I want to know something about 0 through 9, right? If I want to test, say, each one of my 19 vectors on each one of whatever those items are, I need to graft it so that when this stuff comes, okay, 0 through 19 or whatever, it goes, all of those, 1, 2, 3, 4, blah, 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 all hit 0, all hit 1, all hit 2. If I don't do that, and this is flat, what it's going to do is it's going to kind of like just weave them into each other. It's going to go 0 to 0, 1 to 1, and when it runs out, it's going to start cycling back through. Does that make sense?
Yeah, like when you're trying to figure out how many like different options there are for cracking like a 4-digit code instead of it like multiplying.
Right.
Yeah.
Because we're all breaking into safes and stuff. Okay, so anyways, this thing gives me tests basically at each one of those voxel points. So each one of these points for all of those solar vectors, it tells me like true or false. Like this one hits, this one doesn't hit, this one hits, this one doesn't hit. And so all I'm going to do with this stuff, technically true and falses are the same as zeros and ones in computer language. Okay. So what I'm actually going to do is just use a mass addition and just add them up. So basically what this is going to do for me is tell me like which of the voxel points have like significant amounts of congruence with those solar vectors, right? You can see like some have 18, so that means all 18 of them hit. 15, 11, 0 is, you know, 0 is one that could stay, right? 0 has like no conflict with these solar rays, right? So this is just a super clever trick that has to do with the idiosyncrasy of voxels, which again, I don't like understand voxels that well, but I'm like enamored with this trick. It's very cool. When we output the result of a voxel calculation, okay, it's called an isosurface, in this case, isomesh, whatever. And all this thing really is like, it's just figuring out like a kind of inclusion, like what to include, what not to include, right? So you can carve out voxels using image data, all kinds of stuff, right? But just simple Booleans, like this gets put in, this doesn't get put in. So there's a couple things. I'm just going to fix some stuff I didn't do here. So I want to, and you don't have to do this, by the way, it's just an example. So I want to set this channels so that it's just including shape information, not including like the other possible channels you can have, which you can see are like material ratio, RGB, whatever. So one just says it It's only going to have shape data. What's the other thing I need? It's channel here. Get channel names. So these are my voxels. So my voxels are going to go to this isomesh output. I'm going to get the channel. This is sort of stupid, but like a sort of redundant thing, but I'm going to get the channel names, which is just shape. That'll be the channels. Okay. And now the ISO value is what we're going to be calculating, right? What to include, what not to include based on this test that we've done here. So I know I'm jumping around. There's something we need to do. So technically, there's what we care about is this list of vectors, okay? So if right now it's like set up in a way that like if none of these vectors are whatever an issue, it's going to give us a value of 0, right? But because the ISO value is like it's kind of like between whatever and whatever, 0 and 1, whatever we're using. Okay, 19, the list length of this would technically be like, okay, include that. I don't know if that makes sense, but so what I'm going to do is I'm going to add in a list length component so we know the length of the vector list, okay? And then we'll use, basically we're just going to take that 19, right? This should be 19, and subtract these results, right? Which is basically just kind of like flipping this situation around, right? So ones that are like lower or closer to 0 are the things that are going to get taken out, okay? So now I'm going to run that through one more component, which basically is going to give us control over like how strong the effect of this is. So it's just a multiplication, and that's going to go into the ISO value. And then we'll let multiply go between, it's like percentage range. So I could go from 0 to, 90 or like how about 0.99 makes sense actually. So in fact, I'll just make a slider. If I just type in 0.99, enter, that's going to give me this slider, okay? So that'll be the multiply factor, the result. Okay, let's see if this is working. So this is also, this thing takes flat information, right? The ISO value. If we go back to here, like you can see the voxels. I mean, this is a little strange, but none of this stuff is graphed. It's technically flat. So we just need to flatten the result. We could do it here. We could do it there. It doesn't matter. I just need to flatten this. And does it work? Doesn't work. Should work. Let's see what's not right. Invalid mesh. Invalid mesh. Oh, I'm so stoked. Okay, let's see why it doesn't work. What did I miss? Length. Okay, I flattened it. We'll flatten it here, the mass addition. Still turning invalid. It could be to do with the location of this thing. Could also have to do, I mean, this whole setup is like a little funny right now. Let's see, I mean, that should work. That's basically the whole definition. So I'm just going to go to this other one and prove to you that it works. What is not working about it? It could be because the original version that this is set up isn't using that like default box. It's using like a box that's actually based on a curve. So we can try that. If I go back to, I don't know where my stuff is at here. Okay, let's select curve. Select curve. There it is. Okay. So let's try this curve. Set one curve. Okay. So there's my curve. This is like, again, this is kind of weird. It could be some scale issues. I'm not really sure, but you'll see now that this thing works correctly. So it's just some extra stuff turned on that I don't want to see. Maybe I'll just delete that. Okay. This is what I want to happen. Okay. I don't know if you guys can see, this definition is like literally the same as what I just threw together. The difference is that the box is getting generated from an input curve rather than like just a default box for the voxel space. Okay. So I'm just moving this plane around and I've told, okay, I want this plane to be sunny, right? And then it shows me, okay, like you can't build anything that isn't inside of that pink blob volume. Okay, don't worry if you don't totally get that. Like you're not being asked to figure out how to do that. I just thought it would be smart to show you what's going on rather than just give you something and be like, okay, go. So are we cool to look at the actual script we're going to use now? All right, so the big difference between like what I just did and this thing, okay, you can see I've already got it going on something here. So let me grab. Planes. Okay, so in this case, I've done something similar, right? I've given it, and I'll walk through the whole thing again, this whole script, so don't worry. But I've given it this curve as my input. So Aziz has figured out a clever way to translate a curve into a voxel space. It's kind of complicated. You don't have to worry about it. That's different. But otherwise, it's functioning essentially the same, right? Like I've input some planes. I can input planes or, okay, you can see how slow this starts to go. So let's, why don't we walk through a quick example so I can show you like where all the controls are in this thing, because it's not consolidated in a totally clear way. They're kind of floating in different parts of the canvas. Okay, and then I'll explain why you might turn one knob rather than another knob or whatever. Okay, so something that you can do here, this is what I did to solve this problem. You could basically, there's no reason you can't just come, like if you followed me with this thing, okay, with this ladybug setup here, you could literally copy and paste that over and just replace the vectors with this. That works. If you want to do that, I'll show you. It's very simple. So I'm just gonna, maybe I will group this here. So in fact, I don't want this. We're not going to use that. So, but this stuff, if I wanted to do it that way, okay, I can basically just go Control C. Okay, got it copied. I can come into here now, and I'm going to make some space. Maybe we'll just, so conveniently, Aziz has this vector stuff just all hooked into this one little vector component, which makes swapping stuff like this out super easy, right? I can basically drop this thing in. Here it is. I believe it's not missing anything else. If I disconnect this, okay, whole script goes dead. I'm going to remove that from the group, replace vectors here. Okay, that's fine. Same, does essentially the same thing. I can add this into this group if I want. Do that, add to group, and throw this here. The other option, which is what I originally did here, is I did this import location thing, okay, that we did with, it's this component basically, right, to bring in the EPW file, and then through a panel on this, so I can read what exactly the data is it's using. Now, unfortunately, the new version of Ladybug's like language is not compatible with the old version of Ladybug's language. Like, why would it be? You can't just plug location into location. But what you can do is just use this construct location that's sitting there, right? And in fact, yours might already be like this. So if it is already like this, you don't have to change it, right? All I've done is just copy out these different values into their corrective, respective slot. Okay. But this is, I think this is good for you to know if you wanted to, I don't know, change anything about this. Hopefully that makes sense. So whichever way, the results are going to be, they're going to be the same. Okay. So I'm going to keep this as it was, sun vectors. Okay. And now I deleted the little vector. Whoops. There you go. Okay, get rid of this. Add to group. Okay. Something that is this going on here? I think I might have already done this for you. So, okay. Yeah, it's all kind of set. So, all right, let's start with disconnecting some stuff here. So maybe I'm just going to, what am I going to do? Maybe I'll throw a different input in, I guess, to start. So if I throw this input in, set one curve, okay? So the block boundary, this is like where you want to, I mean, it doesn't have to be a block, okay? It's like the sort of volume that you want to develop as a solar envelope. You want to input as a flat 2D curve, right? So you plug that in, and then right next to it here, okay, you've got max height, which is like in meters, right? The unit should be in meters if you're using the Medicine Hat model. The max height of buildings that you want to look at as a possibility. So most of you probably in the, like, I don't know, 4 or 5 stories probably makes sense. I think stories are typically what, like about 4 meters? Anybody? Sorry? 3 to 4. So, okay, if we're gonna do, what, this is be like 20, 4 times 5, 25 maybe on the taller end, it could be possible, right? So let's change this to 25. What that's gonna do, and again, you don't have to follow this through, but basically it's just extruding, it's making this extrusion, right? We're gonna look at. All right, so the other thing that we need to do, and by the way, so the sun path diagram is turned off right now. Okay, the thing that I was showing you before. So if you want to see it, if you right click on the sun path component, or the way I like to do is just click on the sun path component, right click and just turn preview on. Or you can also middle click, you can use the funny blindfold dude versus unblindfold dude. And it shows here. Now this looks like, again, it's an older version of Ladybug. I don't understand what's up with the text looking all humongous. Instead of showing you points, it shows you little fiery sunballs, sun spheres. Fine, okay, but so same thing, right? We got sun path scale, so you can scale it, right? You can see your data points, which are these yellow dots, right? To get your thing set up.
Those labels are annoying.
Yeah, there should be, let's see, can we turn off those legend projects? Sun scale? I don't know what those things are. They're annoying, but I'm not seeing a thing.
What's the max height part? Was that like the max height of the jump?
That you want your building to be.
So the max height part right here is the max height that you could build, right? So when I input something like I've done, right, that's getting extruded up, whatever I said here, okay? All right, so the other thing we need to do to make something happen is input some stuff that we want to be sunny, basically, right? Aziz has labeled the structures as like sunny surfaces and sunny meshes. So for this, you can actually put in like whatever you want. It can be 3D and it'll work the same way. So like if there was a building, for example, that you didn't want to cast shadow on, you can do that here.
Like any urban gardens, right? Or a park that you want it to be sunny. Or a building that needs to be in sunlight all the time, maybe like a greenhouse.
Right. So this can be like basically anything. I'm just gonna throw in, like I was doing before, I'm gonna input a surface, okay? So this is just a Rhino surface, nothing complicated. That would get input as a BREP. You can input meshes as well. So if you're inputting a mesh, you wanna right click on mesh and throw mesh into there. If you're using NURBS, it goes into BREP, okay? Everything winds up getting converted to mesh. You don't have to really worry about that, but it's just probably the only thing to note. So, okay, that's plugged in. Let's see, this should be working now. So is something not working or something's turned off here?
You were using closed, like a closed poly surface, you have to convert it to that.
No, you can plug in a closed poly surface. You just put it in the BREP. It's fine. Okay, so I'm just gonna, interestingly enough, like nothing happened, which is not what I was expecting. So let's figure out why nothing happened. So we've got a curve here, so that's fine. I'm just gonna check this. So basically, maybe I'll quickly just explain this to you guys. The first grouping, these regions, right? These blue regions are groupings of components, right? The first one is just about calculating like the right box to use for the voxels. There's a little slider here that refers to like edge length, and this has to do if you're using a curve, right? If you're using something that's not like a rectilinear like polygon, you can change this and it's going to impact the performance of the script, but really all it's doing is just trying to find the best fit box. And you can see that, okay, this is what it's giving me as a box. It's not actually using those filleted edges and whatever, and that makes sense for the voxel thing. Okay, there's voxel size in this voxel resolution one. This one is about, I guess, also just managing the efficiency of the voxel input here. So the size is super critical. I think by default, this thing was set to 5. And so if it is set to 5, you can see, this is like the resolution of your thing. And so depending on how big your like curve is or whatever that you're using, you're going to need to mess around with this, but you want to be careful because if you plug in like something huge, which I did, right? With the whole site, and that's set to 5, it's going to crash it won't crash, but it's going to crunch for like, I don't know, like an hour. Okay. So be cognizant of the voxel size. See, in this example, I actually need more resolution. Like my voxels are like relative to the size of this site. I need actually more resolution to get like a meaningful result out of this. Okay. So that's what I'm turning down the resolution, something's happening. But if I, for example, went back to using like this larger curve, right? I'm gonna want to set that up to something like 10 or 20. So if the thing is going super sluggish on you, this is most likely the parameter that's causing the sluggishness. Okay, so let's see, what else do we need to know? So this is working, it's making a weird looking thing. Basically, let's see, from here, don't need to worry about all that. This is like the setup we did in whatever monolith, right? You don't need to worry about that. Okay, this one, that's calculating the ray inclusion booleans that we did. You don't need to worry about that. This is a useful thing in the end here. There's a couple, so towards the end of the definition, see where I am, like way over here now, right? This slider is useful, which is labeled as percentage, which again, this has to do with the ISO value that's getting input here, which is, we can basically equate to like how much of the vectors in the test that we're going to care about, like that we're going to include. And so you can actually correlate this value to like mean, like depending on what you set up in your ladybug experiment, right? Like
Percentage of sun.
the percentage of sun, right? Like the percentage of those hours that are meaningful, right? So you can see this is, if I set that to 0.5, it's only taking like half of those vectors into consideration, right? And then the other ones get to stay. If I set it all the way up to 0.99, it's like all of them are considered, which means at all of the hours that you input, this site is sunny, right? So down this way, only some of those hours, this site is sunny, right? Like 73% of those hours, this site is sunny. Yeah, does that make sense? So super useful slider to be able to like, yeah, I want this site to be sunny, but I only care that it's like sunny half of the times that I'm testing, right? Or all the times I'm testing, right? All right, so the only other thing to understand is how this mesh is getting processed in the end, which this is just a visualization, okay? It's not truly intended for you to like find a cool looking thing and be like, yeah, that's my building. It's really just like an envelope that tells you like feasibly, like very literally, if you build here, it will or will not cast shadow on this thing that I care about. So that said, I'll explain this. This is what, just for interest's sake, this is what the voxel, the ISO mesh looks like. Let's do custom preview on that so you can see it better. Okay. It's kind of weird and funny looking. Yeah. The higher the resolution, the smoother it is, right? So if I went back to my voxel size and I started to reduce this number more, like make them, of course now it's like wants to crash. Maybe I shouldn't have done that. We should probably take those 2 zeros off of that thing. Should really just be like maybe 1 0 is what you have to play with. But like if I actually accidentally just threw in like 0.01, like that's probably bad news. What's 0.01 meter across like an urban scale building? Yeah, that's crazy. We'll get it back.
Clearly, so you're just gonna say where it's on. If I hit this calculation, it's slow and I have to we don't like the calculation.
I wish. No, so like if this happens, it's not responding, it will eventually come back. Like it will succeed at some point in, like it's not crashed. It's, you know, I mean, it is crashed. But I can tell you from experience, like it will finish its thought. It's super robust that way. That said, save a lot. And if this happens to you, like I often get impatiently, I don't want to sit around waiting for this. I'm just going to force quit it and reopen the thing. And then I'm going to be like, I'll show you, I'll do it right now. I'm going to be careful.
You say?
It doesn't matter. Like I didn't do anything really to it. So let's close the program. And I actually realized like the script I gave you guys should all be like ready to go. There's not really any, I'm talking a lot of detail about how it's working. You don't actually have to know that for the most part. I still think it's good to have an understanding of it. Okay, shops, I just need to file. We're doing okay on time, right? Not too long.
This is the only thing we have left.
Yeah. So I made this study area file, that's what I was using. And so what I'm going to do to be careful is like, before I reopen that grasshopper definition, I'm going to make sure that at least one of the inputs is broken. So it doesn't start recalculating the second I open it. Right? Okay, we're fine. It looks like the plane that I was using in that calculation is like gone. So my guess is it's going to open the way that it did the first time I opened it. But if it wasn't gone, what I would have done, like there's like a plane I drew somewhere up there, I would have just deleted that plane. Or if you are worried about losing that, just like get its outline curve or something, say like dupe face border, so you have the curve and you can make it a plane again easily, and then delete the plane.
Our hope / expectation is that you'll be able to use this script in order to further refine massing when applicable. Many of you have a lot of programs that would dictate a certain amount of sunlight being available to adjacent sites, whether it's a garden, a park, another building. So rather than just have, you know, gabled roofs
Right.
or extruded volumes that are next to like a plot of land that's going to be an urban garden or a farm, you can now begin to articulate what those massings would need to be, or in what shape they would need to fit inside to not cast shadows. So this doesn't mean, for example, that the building needs to be that shape. You could put a cube within the envelope, and as long as it fits, it's not going to cast a shadow
Right.
onto the little those two green spots that has selected.
Let's try to, okay. I don't know about this. Just be real careful with that voxel size slider. Like part of me wants to right click on this and be like, okay, I'm gonna like, give it less significant figures maybe. Or something, just so I don't accidentally like choose such a tiny increment, right? Because what's 0.01 meters is 1 centimeter now. Yeah.
No, it's
It's
0.01.
Yeah, that's what it could have been at
Yeah.
1 centimeter, which is absolute nonsense, right? Like you don't need that level of precision. So if I set this to just have one significant figure, it means I could have 10 centimeters, which is probably still nonsense. So maybe we actually just get rid of the zeros. There you go. So it's only in integers rather than these like tiny little increments. But that's how you can adjust that if you need. But so what I was trying to show you before my Rhino froze, okay, was to do with what's happening in the very end of this definition. So we're going from the ISO mesh, which looks like that. Okay, it's this like kind of crazy looking thing. And of course now, try not to make the same mistake again here. I'm gonna reduce the voxel size just a little bit. So if instead of dragging the slider on something like this, it's better to maybe double click into it and like hit a number in that makes sense, so like 8. Should make a little bit more resolution. And the only reason I'm drawing your attention to it is because technically the higher your resolution, the nicer the ISO mesh is going to be, right? Like the more accurate and the smoother it's going to be. But in the end, we're choosing, at least this is the original design of this definition, is to not actually use the ISO mesh, which again, if I undid that and I enable mesh wires, I mean, that's not like a crazy resolution mesh, if I'm being honest with you. It's not so bad. But Rhino isn't great at dealing with mesh, which you guys probably have a sense of. So what's going on in the end of this thing is basically there's this one, I got rid of, this was a CIA Center for Civilization component originally, which is just flipping the mesh normals, which I got rid of. But it's basically just, so this is this custom component, which is just like the reduce mesh command in Rhino. You guys maybe know, have used that, right? If you want to reduce a mesh.
Yeah, technically this is a plugin that was developed for our lab that we're making available to all of you.
Yeah. So it's pretty simple. I mean, you're going to want to, the accuracy is from 1 to 10. You're most likely just going to want to leave that set at 10. In fact, I might even just put that in a panel because I don't know, like maybe it's interesting to play with the value, but if it's just, you know, sitting there like that, it could just be set to a number without a slider. But what you will want to play with is the face count. So like the target face count, and this is a desired number of mesh faces, right? If I start to slide this thing down, I'm going to get like a lower resolution thing, right? Which may or may not be useful, but I think the idea when these guys are coming up with this thing is you're going to be like running this on like a city scale thing. So your thing is not city scale exactly, it's still big. But so the original advice was like, well, find like the solar envelope, you know, the most reduced thing that still seems right. don't over reduce it so that it doesn't make any sense. But you don't need like the super high resolution mesh. You can reduce it and still have the same functionality for, what it means. So that's basically all that's going on here. I wouldn't touch, I don't know why there's a slider on this unweld angle. I mean, unless something's like really not rendering correctly in the end, I wouldn't play with that at all. I just leave it alone. And you can play with this if you want to have like lower res or higher res representations of the solar envelope. And then once you've kind of figured out what you need, you bake it, right? And then just bake it out in the very end. Just probably, I'm going to assume that makes sense. So let's try baking out of that disjoint component. Right click on that, bake. And yeah, okay, so I don't know. No, that's right. There you go. It's green because I have it on a layer that's green. So there you go. Okay. So yeah, does this make sense? Hopefully not too like, I mean, I know I probably made it more complicated than it needed to be, but I think for the most part, this script should just work for you.
I wonder if it's still recording.
Oh, you don't think so?
Um,
Yeah.
Oh, okay.
Should I, maybe we can pause the recording now? Is there, or,
Yeah, I think maybe you're really doing that. So in the example, we had people had created like example geometry or like conceptual like let's say of this, where that was like another script compared to this, or just totally on its own basic what came out of it.
like from the studio?
Yeah, the last studio, there were like graphics that were created from this sort of.
I mean, there's a lot of other scripts going on. But
Yeah, that studio that I taught was basically every week a new grasshopper definition that then